Who has used Git before? Is there anybody who had never used any kind of version control? Git or CVS, or no one uses that. Who am I kidding? Subversion, anything like that? Okay. So what's the purpose? There's several things, really. There's several advantages to using version control. One, you might think, well, as long as I take backups, I don't really need to do it. But let's say I've been coding away for 7 hours, and I realized I made a decision like 4 hours ago that changed everything I've done since then, and I've decided now that that was the wrong direction. And I cannot remember everything I changed. So I really wish I could just rewind the clock. So even though I'm the only person working on the thing, and even though it's still the same day, I really wish I could rewind and go back to when I made that decision. Well, with version control, you can. You can rewind the clock and go forward in a different direction. Let's say you're on a team, and somebody else changed code. And, well, if you don't use version control, then you've got a big mess in your hands. If you're both just changing the same stuff, you're going to break each other's stuff all the time. And also, it's nice to have good commit messages under those circumstances so you actually know why the person was changing the code that they changed. Suppose you used version control, but you just made your commit messages things like made changes or update. Yes, I've seen commit messages that bad. Just update. Update what? Well, when you're on a team, you can see the other person's changes, but you don't know why the heck they did what they did, and you don't want to have to read every single line of their code to figure out what they did. So it's nice if you can just look at the log and see, oh, okay, that's what this was all about. Suppose, again, that you're not on a team, but 2 days have passed, and you don't remember what the heck you did. Again, good commit messages would be very nice to have there. So back when I didn't use version control, which was a very long time ago, thankfully, I really did think backups were all I really needed. And that was kind of the only purpose of version control that I understood. And then all those things I just described happened to me, and they were very painful. Another big one. Suppose you deploy a change to production, and 10 minutes later, you get a panicked phone call that you missed something. There's now an error on a different part of the app that your release caused. You could try to troubleshoot that really quickly, but they need it working again. You really just need to undo your change because you're not sure which part of it actually broke this feature, and it could take you a while to figure it out. So again, you really need to just be able to rewind the clock, push the old version, and then start troubleshooting. So, version control, a very good thing. And in this class, we're using Git. Git is very nice. It's a distributed version control system, which means that everybody has a copy of the entire repository. You have all the old versions on your machine at all times. You don't have to get them from a server. You can store them on a server as well, but you don't have to. Yeah, you have a question?
So what do like big companies like Facebook, Snapchat use?
Git.
They use Git as well.
Yeah. Facebook uses Git. Microsoft uses Git.
Like, I need to code their app to app.
Mm-hmm. Yeah. Now, Microsoft has Team Foundation Server and all that stuff, but they run Git under the hood for that a lot of times. Yeah, when Microsoft switched to Git, that's a big deal. Microsoft is actually the single biggest contributor to GitHub. There's to open source on GitHub. There are more Microsoft projects in GitHub than any other company. Pretty weird because they had their own solution for many years, and they still do with Foundation Server, but or it's called Team Services now, isn't it? But you can use Git, the Git engine, with Team Services. So yeah, even Microsoft is using it. React is, of course, open source and is made by Facebook. That's on GitHub. So they're not all bad, just mostly bad. So we've been typing all these commands without really talking about what we're doing. So by way of demonstration, and because it's a good idea anyway, let's create a README for this project. We can do it any of the ways that we've learned. We could just do touch, and I'm going to call it all caps readme.md. Anybody know what MD stands for? Markdown. It's a nice plain text file that can be translated into HTML to be presented nicely, but it's also nice and readable just in Markdown format. If you didn't have something with bulleted lists, how would you probably do that in a plain text file? You'd probably either use hyphens or stars, right, on each line. Well, that's how you do lists in Markdown, and it will get turned into HTML lists when you actually view it on GitHub. So now we should have a README file here. Here it is. At the top, we'll just say hash space user directory. That's how you do headings. A second level heading, an H2, would just be 2 hashes. And you know what? That's a pretty good way visually to break up the page anyway. So again, it's nice and readable even in the native format. The first project in Extern Bootcamp 2018. And what do you know? That's a paragraph. Just put a blank line to make a second paragraph. All right. So now if we type Git Status, we have an untracked file. It tells us nothing added to the commit, but untracked files present. Use git add to track them. So where is README right now? It's in the working directory. So the changes you've made, well, right now it's untracked. To even get it to pay any attention to it, we have to add it first. So we'll go ahead and add that real quick, and we'll commit it. Add README. So right now we've committed it, which means it's in our repository, but all this is still just happening on our local machine. Let's make a change to that existing file now. This project demonstrates the following, colon, and let's make a little list. Put a star there. Handling events in JavaScript. Now if we do a git status, first of all, it's telling us that we haven't pushed something. But again, we have a change not staged for commit, which means that our modifications to README are in our working directory. So that's the current state of things. The way your files look right now, that's called your working directory. Before you can commit them, you must first stage them. That's what it's saying here. Changes not staged for commit. So if I type commit now, it wouldn't do anything. But if we use git add, then we've added them to the index or the staging area. And those are the things that will get committed if you say commit. So let's say git add README. Or git add dot. We'll just do all the files, right? Now if I do a git status, we have changes to be committed. They are staged. We could use reset to unstage. So that change that we made has moved from the working directory to Git's index or staging area. So it is the thing that will get committed if we commit. Once we commit, update README. Now it has moved from the staging area to the actual repository on our machine. If we do a git log, we'll see those commits. Add readme, update readme. Now I haven't pushed in a while, so if I look out on GitHub at my commits, I'll see 7 commits. The last one was get the input value via the event target. So notice I made more than 1 commit before I pushed. That's fine. When you push, it will just push all the changes since the last time you synced. But you don't even have to have a GitHub project or anything associated with it. You can do the entire repository on your machine. Now, if something happens, like, say, while you're teaching a class, your entire desk falls off a stage about that high, and the desk lands on top of your laptop, and you need to call the friend you barely know and ask if you can use his Apple discount to buy a new laptop and then run back to class real quick, for example, you'll be very happy that you also synced your repository with a remote. Just in case this ever happened. I'm sure it's never happened. Totally happened to me in the middle of class, a half hour before the Apple Store closed. Yes, sir. I think it was 15 or 20. It was substantial. Yeah, I think it was 15, which, you know, on a $2,000 laptop is a lot of money. $300 off. So, let's push. Q to get out of git log. There it goes. Now what happens when I push? It goes to a remote. You may remember those 2 commands that we copied out of GitHub when you created the new project. The first one was git remote add. So you have no remotes when you just do a git init. But you can add one. Git remote add, and we named it origin. Git remote add origin, and then the URL of our GitHub repository. So your remote could be named something other than origin, but origin is typical for the remote that is going to be kind of your source of truth. In our case, GitHub. So git remote add origin, and then the second command was git push. Git pull is the opposite, from the remote to your local copy. If there are changes up there that you don't have yet because you're working with a teammate, or maybe you're updating the same code from more than one machine. And you can have more than one remote. If, for example, you're deploying to Heroku, you might have another remote for Heroku, and you just deploy by doing a git push to that. So I will keep referring to this for a little bit as we make further changes. Yeah, or you can take a picture of it. That's fine. So that's a quick intro to Git and GitHub.